And today we're having Sam with us. Sam, what's up? Um, he got a tough one, and he had a lot of fun. Sam is basically the founder, and he's actually running IndieQ meetups. You have got 120 subscribers already. When we first met, like we met through Twitter, because he was looking for someone to, kind of do some of the Qiskit live reading sessions, and I kind of said, hey, why not? Um, why is this liking so much? Anyway, so yeah, pretty cool stuff. You can follow him. You can follow IndieQ meetups in Twitter. You can follow him as well directly in Twitter. And I'll just put all the links and stuff down in the description. And let's see how Sam did with the challenge.
Hi everyone, I'm Samanda Sharma. I am a Qiskit advocate and the co-founder and organizer at IndieQ Meetups. More about that at the end of the video. But right now, I've been invited by Quantum Intuition and by Daniel, however you know him, to solve this quirk puzzle, Rubik's Cube. And yeah, let's get started. So the idea over here is that we have a black box circuit over here. We don't know what it is, and these all these qubits have some operations being done on them, and we are supposed to use the tools from this toolbox over here and try to bring the probabilities down of each qubit measurement to 0, or to turn the qubits off, technically. Right, let's get started. So my first instinct usually would be to go after the Pauli gates and the CNOT gate and the Hadamard gate, because usually like a lot of common circuits are composed of those gates. So let's try those out. See what effect we have on our circuit. I'm trying out the X gate, and I definitely see a bump over here and over here. So I know that this, like these two qubits are definitely in the X space. Let's see what Y does over here. Oh, Y does the same. So a combination of X and Y. This is unaffected. Let's see. Okay, so H is affecting this. Hadamard gate is affecting these two, but not these two in the center. It affects these two in the end. What about the Z gate? No effect at all. Huh, interesting. There's no point using the swap gate right now. How about half turns? Do half turns do anything? Anything different? Not really. Not much different. 50, 75, 25, 50. 75, 25, 50. Yep. What about this? Let's see if the Y gate does something, but it affects these end measurements, which is interesting. Okay, so this is in the YZ basis, I guess. What are the T gates not doing anything? Here's the T gate, it does nothing. About quarter, like, sorry, eighth turn measurements. Not too different. Not too different from okay, that's definitely interesting. Huh. Now what can I do with a combination of these? Not seeing any significant improvements, but let's see if the Hadamard does something for us. Brings both of them down here. Now I also know that this is in the Y basis. Nothing. Does that do anything for us? But this ends up affecting qubit number 3. Very interesting. Let's start afresh. Let's see what more we can find out about this. Let's try C not gates. All right. Okay. No effect here. Uh, what about here? Nothing? All right. Nothing too important. And T-gate does nothing here. Can I try and bring this down? Chance I can correlate these? No. Okay, what do these do? I see a lot of post selects here, and I haven't tried these out in a while. Maybe I'll wait and see what I can do with them. Okay. And this just ends up in, like, raising the probabilities again. Bring it down. I want to bring it down. Okay. All right. This works. I'm missing something here, definitely. Do swap gates do anything for us? Nah, they just shift the probabilities. Don't need that. What else can I do with this? I know that these are affected in the Z basis, but not getting too much out of this. Okay, what if I do this? Let's throw this out. This is not being affected at all. Unless I use this. This brings it down to a decent number. And then H again. How can I... It's not too shabby. Will this help? Okay, I'm getting no clues from these. Should I try these out? Like maybe see if the probes have any effect. Because I haven't touched these in a hot second. Nothing from the probes. Oh, okay. Oh, and this one went completely on. What does that mean for us? Maybe if I just keep it for a second over here and see what we can get out of this. Oh, okay. So the first qubit went completely off when I did this. The second one is completely on, and the ones at the center have a 50-50 chance. Okay, so this one went off too. Should I try the other ones as well? Now repeating these won't help. What about this? Oh, and we have another gate off. Great, great stuff. This just switches them back on again. Yeah, this is not particularly helpful. Maybe but if it's using these three gates, if it's using these three probes, it should be using this one as well in some capacity. I'm just talking about symmetry here, guys. Like it seems like the black box was created just by dragging these four in different combinations. Right now I have 2 off and I have 2 and 50%. This one gets completely on when I do this. X. This doesn't help. Another edge doesn't help. How about I keep... Oh, wow. Oh, this is great. This is going really well. That last one went really, really well. What else can I do? Maybe try dropping this now. Oh, and it's 50%. What if I keep these here? This, okay, Z still has no effect. Y still has no effect. X still has no effect. Maybe try this with quarter gates. Oh, this... And this gets completely off. But keeping it here switches it completely on, so I'm guessing maybe inverse X would do the trick for us, and it does. And it does. There you go. All the qubits have been turned off, and I guess we have completed the challenge. A bit of an unorthodox method, but I think we got the results, which is really what matters. All right, then. Thanks again for having me on this challenge. I'm not sure if this is the most optimal way to solve this circuit, but I would love to know like what this circuit really was and what's the best approach to try out solving a black box circuit and try to find out how to solve an unknown circuit when you don't know. So I would like to know more details about that process and what you guys think. Maybe you guys want to try this out. All right, that's all from me. As promised, I will share more details about what I personally do. So yeah, I'm part of a group called IndieQ Meetups, which is a student created initiative. It's a group that is working to increase awareness and education about quantum computing in India. And for that, we organize events like hackathons, study groups, and all kinds of things related to quantum. So we already have a strong group established, and we aim to be more inclusive and more diverse. And it's at the moment, since all things are online, so we don't want to keep this restricted to a single country, but because all of our resources are online, we invite everyone to join the initiative and help create like a global community for quantum computing education. So this you can find out more information about us on our webpage at indieq.org. That is indiq.org. Here's some more details. You may be interested in checking this out. We also have our meetup page over here. You can join the group and stay updated on future events, meetups, all of that stuff. We also have our YouTube channel where we post our content. We have a bunch of discussions and just quantum computing interviews and stuff already on our channel. So if you're interested in that, please do check it out. And let's be honest, like if you're watching this video right now, you're definitely interested in quantum computing. So do check out our stuff at IndieQ Meetups, and also don't forget to check out Daniel's YouTube channel, Quantum Intuition, for more content. Here's our Twitter, in case you might be interested to stay updated with all the latest stuff that is happening with our organization. And that's it from me. Thanks again for inviting me, Daniel. I really appreciate it. and I will see you guys next time.
So what do you guys think? Sam, you cheated a little bit, but it's fine. I'll explain that again. Those are postulate gates. Those gates are here to basically help you guys inspect or kind of explore the circuit, but they are not supposed to be used. Maybe I should put it somewhere in here as part of the solution. The idea of post-selection gate is like a measurement where you're then kind of just selecting that particular state. Um, so in here, if you post-select for on plus off states, what it means is you're basically, I hope the sound, because this is lagging a lot and I don't know why. So what this is essentially doing is kind of post-selecting, so it's measuring these qubit and then just keeping the states that are in the plus state, right? So it's a kind of, it leaves these qubit in the plus state. That is kind of a little bit of cheating, I'd say. But it's the idea is it allows you to inspect, okay, like what are the chances I got, like what happens, because I don't have a view of the system overall. This at least tells me, okay, so 50%, like this 50% of my all possible outcomes are omitted if I postulate here by 0. It kind of means that, this really is 0 and a 1, which kind of fits what you have with 50% here, right? But the idea is you can take a look and check, okay, is this value in maybe, the superposition that's in here. I hope this like is not, yeah, anyway. So, yeah, but that's good. So I already explained in the previous video what are different ways to approach this problem, where you would basically, play around with the inputs and see, you kind of start seeing that just by changing this input, this qubit is already turned off, right? So what it means is those qubits must, or they must be related somehow. There's got to be some entanglement in here. I mean, this can tell you as well, the post-selection can tell you as well whether there's an entanglement. That's a useful intuition as well. So if I open Quirk and I entangle, let's say that I will just do a really basic Bell state, right? So if I post-select on 0, you can see that affects that qubit as well. So it's actually telling me they are entangled, right? So that's another way to use post-selection, because this means my measurement has affected another qubit, and so this means they are entangled. Good. Yeah, I hope that was helpful.